First thing, just let me, you guys have I just gave back pop quiz number 2. We're doing okay as we move along. Some little things you just want to take a look at and remember for future quizzes. We do have the third one coming up on Monday. Real quickly, on Monday, the third one's going to cover 2 questions. Theta equals S over R using that formula I showed you yesterday and you guys worked on in class and on the Delta math. Okay, just a heads up. Anybody remember if you're going to use this formula, what type of units do you need? Radians. You need radians, all right? So if it happens on Monday that I give you it in degrees, you got to convert it. Just a heads up. Okay, so make sure that's in radians. And then the other one is finding a coterminal angle. Okay, finding a coterminal angle. So if I give you, if I give you 220 degrees, how do you find an angle that's coterminal, either positive or negative? I'm going to ask. Doesn't matter, positive or negative. What do you have to do? You can add 360, or you could subtract 360. But what if I pull this on you? What if it's in radians on Monday, and I ask for a coterminal angle because you can't add or subtract 360 now? You could convert it to degrees and then convert it back to radians too at the end. That's always good too. Yep, that's fine.
2 pi.
Add it or subtract what instead? 2 pi and get a common denominator. Yep. Okay, so you might want to take a look back at those stuff because that's what the pop quiz will be on Monday. All right. Questions there? So I just wanted to give you a heads up what to expect on Monday, the 2 questions I'm going to ask you. All right, let's roll, man. I think this will be hopefully a short day here. Yesterday I introduced the quadrantal angles, 90, 180, 270, 360, and we said let's turn them into radians, and I wanted you guys to become more familiar with them. So let me start 180. Anybody remember the radians in 180? Just 1 pi. Anybody remember 90? If you're gonna look, you got to look back. 90 was what? Pi over 2. Okay. Anybody remember 270?
3.5 pi.
3 pi over 2. And then when I go back to 360, it's what?
2 pi.
2 pi, yes. These are some I'd like you to become familiar with without having to spend the time to convert. And there are 3 others I'm going to show you today that I'm not going to say memorize them because you know why? We're going to use them so much, they're just going to come naturally. All right, and those 3 are the following here. The first one's 45 degrees. Okay, 45 degrees, which is pi over 4. And just get used to today, you're going to have to flip back and forth to this page a lot. But hopefully soon enough you don't have to flip back because you're going to know it. And I really don't know why I gave you all these diagrams, but because I'm only going to use a piece of each. So 45, pi over 4. 60 degrees. Get familiar with without having to convert. Pi over 3. Pi over 3, 60 degrees. And then the final one is 30 degrees. I want you to become familiar with, and that's pi over 6. Okay, so all these that I have on your paper right now, I'd like you to become familiar with without having to convert. If you have to, you have to, but hopefully they just come naturally. How do you feel if I give you an angle and you find the reference angle? Don't have to write this down, but let's say I give you an angle in quadrant 2. I know angle in quadrant 2, 160. Find its reference angle. You guys comfortable finding the reference angle? Which would be what? Anybody, the reference angle? Thought you said you felt comfortable.
20.
What's this reference angle here? 20, yep. Here's what I'm going to do today. I'll give you the reference angle in the quadrant. You give me the angle. Okay, so I'm going to say going backwards, but I'll give you the reference angle in the quadrant, what must have been the original angle to begin with. All right, let's roll. again, if you got to go back and forth, because all this is going to be in radians. So if you got to go back and forth, go ahead. All right, so let me set up the scenario right now. Let me set up this scenario. I am going to give you the reference angle and the quadrant we're in. You give me the actual angle. Okay, but everything is in radians. All right, everything is in radians, and then we can go degrees at the end. So my reference angle is pi over 6, and it's in quadrant 4. Ready? Pi over 6. If you got to flip back, let's start. You do it. Everybody do it. All right, don't just rely on a couple classmates here. I'm pi over 6. What is that in What is that in degrees? Pi over 6. 30 degrees. Done. All right. If you want to make a little note, it's 30. I am not requiring a diagram, but I think it helps you guys at the very beginning to see a diagram here. I'm in which quadrant am I in? 4. So I'm going to make a reference angle right now with you in quadrant 4. Okay. That is 30 degrees. Quadrant 4, reference angle of 30. What I need your help with is, what's the actual angle theta there? Okay? Well, we got to discuss it here. Let's not yell at everything out here. Okay? It's got to be in quadrant 4, and I already know that reference angle is 30. So everyone start thinking here. Start thinking. Punch some numbers in your calculator if you have to. And I'm going to keep to my word here. Jeremy?
So we know that this is quadrant 4, and so that means you have to take 360 minus 30, which is the reference angle.
Yep.
You need to get 330.
Okay, so 360 minus 30, which is the reference angle, gives you the rest of the angle, which would be 330 degrees. Yep. Okay, whoa. It said also find the angle in radians, then write it in degrees. All right, I went backwards. I wrote it in degrees, but now we still need it in radians. But here's what I'm going to do today. No converting. No converting. I don't have time. Ready? Watch. This is going to be nice. Nice. You're going to like this a lot. Pi over 6 was 30, right? Here's what I need you to do real quick on your calculators. How many times does 30 go into 330? My answer. How many times does 30 go into 330?
11.
Find it on your calculators. Go ahead. How many times does 30 go into 330? How many times?
11.
How many?
11.
Ready? Okay, watch. What was 30 degrees in radians?
Pi over 6.
Everyone, pi over 6. That's one we're going to start knowing. And how many times did 30 go into 330?
11.
All right, we're done. We don't need to convert. There it is. That's why it's so nice to know these off the top of your head. Okay, pi over 6 is 30. 30 goes into 330 11 times. 11 pi over 6. Done. All right. One doesn't make you great, though. Let's keep grinding. Pi over 3. Look back if you need to. Pi over 3. Pi over 3. Keep looking. Keep looking. It's 60. So everyone go ahead. If you need to draw it, go ahead, draw it. A 60-degree reference angle in quadrant 3. Don't say a word what it is. So draw a 60-degree reference angle, x-axis, terminal side, 60-degree reference angle. Now let's take a look. What is the actual angle in quadrant 3? Think about it. I'll ask somebody. Think about how I would find that angle in quadrant 3. And make sure you shouldn't be giving me an angle less than 180, right? That's in quadrant 2. You should be giving me an angle more than 180, but less than 270. Let's see. Olivia, got anything for me?
2,
Good. Almost. Where'd you get the, maybe you're just doing the math. How are you getting 210?
I did 270.
Oh, whoa. Where's 270? On the Y, right? I don't want to use the Y axis. The angle's formed on the X. So ready, Olivia? What's this angle right here on the X? 180. And then I went how many more degrees from my reference angle?
60.
Okay, so what do you want to do with the two? 180.
Minus 60.
There was 180 and you went more, right? You added on, right? Plus 60. So what's my angle there? 240. There you go. Everyone see that? I went 180 plus an extra 60, my reference angle, to get to 240. Questions? Think we convert this pretty quickly? Let's see if we can do it into radians. 60, right? How many times does 60 go into 240? 4. What was 60 in radians? Pi over 3. And you said I did it 4 times. 4 pi over 3. That's a nice little conversion, huh? You don't have to wait anymore. Okay, quad 2, pi over 4. What do you got? Pi over 4. Pi over 4. Look back, pi over 4. 45 degrees, yep. So everyone do your best. Draw a 45-degree reference angle in quadrant 2. X-axis, terminal side. 45 degrees. What's that angle in quadrant 2? Bigger than 90, less than 180. Gotta be. I like the clicking of the calculator buttons. We're trying stuff out. Hi.
Hi. 130.
How you getting there?
I did one. So I took 180.
Yep.
And 45. And then
You never use 90 or 270. That's not on the X. 180 going all the way over here minus this reference angle. Because look, everyone see I'm going backwards now. So I got to subtract the one. I got to subtract 180 and what else?
45.
45 to get
135.
135. Let's quickly convert it into radians. It was pi over 4. How many times does 45 go into 135? 3 times. 3 pi over 4. Anything you want to ask here? Because I wanted to do an example in all the quadrants. I'm not doing an example in one because we know it's the same angle. The reference angle and the angle are always the same. Good. Yep. Around.
Numbers on B.
Yep.
Did you add 180 to 60?
Okay, because my angle's in the third quadrant, right? So I'm going from 0 all the way to this side right here, right? So as I go from here to here, how many degrees did I go? 180, right? But then I had to go that extra 60. So that's why I added on 60, because I went 180, but the angle stops here now. Doesn't stop here, doesn't stop in the second quadrant. I had to go 180 plus an additional 60 to get to that line right here. You sure? Okay. Versus here, I went backwards, didn't I? I could go 180, but then I'm like, oh boy, I went too far. So I needed to subtract off that 45 to get here. Okay? Good questions. Anything else? All right, here we go. And this isn't about quickness, it's about understanding. No reference sheet. On a test or quiz, you could always use it, of course, but I'm trying to get you guys to the point where we know what these angles are. I want you to just sketch 5 pi over 6, negative pi over 4, and 7 pi over 3 using your knowledge of what those are equal to in degrees. Ready? 5 pi over 6. We see a pi over 6? All right, 30, pi over 6. 30 times, what's with it? 5. 30 times 5 on your calcs? 150. Graph it. That went pretty quick, just by knowing what pi over 6 was. See 150 closer to 180 in quadrant 2. And some of you guys are just forgetting your rotational arrows on your pop quizzes. Make sure you got your rotational arrow in every time. And then there is a second part to every question here, which is find the reference angle in radians. Reference angle. You knew that was one, and hopefully you guys are going to start coming up with a little pattern here, hopefully, but that was 150, right? Reference angle. What's that reference angle right there?
30.
Can we say it's 30? Everyone's all right, 30? But it says what? What does your angle have to be in? Radians. What's 30 degrees in radians? Could I have gotten that off of just knowing the angle to begin with? Everyone see, do you see the relationship between the angle and the reference angle? Take away the 5, you got your pi over 6. All right, let me start asking people now. Negative pi over 4 without even converting. Look back if you need to, though. Pi over 4, negative pi over 4. In degrees, 19. 17, Sarah. There you go, negative 45. Don't need the reference sheet there. All right, let me keep asking you questions. What quadrant am I going to be in if I graph negative 45? 2's, Jeremy, what quadrant?
So it'll be in quadrant 4.
4, good, yep. And look at this. This is a halfway one. First time we've had this, huh? Halfway in between both of them. When you got to draw your rotational arrow, what do you got to remember? One eight. Oriana, where's my rotational arrow going to go? Negative 45. Count going this way.
No,
So
oh,
clockwise. Yep. There you go. All right. How do you want to find the reference angle here? Because remember, this is the reference angle right here. X-axis, terminal side. I don't want to use the y-axis. So how can I, remember, it's negative 45 right now. How can we find the reference angle? Mike?
360 minus 45.
So, okay, I'm going to add 360, which is basically what you're doing. Yes, you're just flipping it. Yep. Which gives me an angle of 315. Okay. So angle of 315, because I know you guys like to deal in positive angles when finding a reference angle. So if I have an angle of 315 and I'm asking you to find the reference angle. Angle of 315, how do you find its reference angle? 360, Sarah, go ahead. 360 minus 315, and where do I end up? The reference angle is positive 45, yep. Which is what in radians? Pi over 4, yep. Anybody seeing a pattern here with the angle I give you and what the reference angle is going to be? So maybe let's see if we can establish this pattern for the last one without having to go through all the work. 7 pi over 3. First question is pi over 3. 2, 1, nope. 8. Connor, pi over 3, what do you got?
I got
No, just pi over 3. What is it in degrees?
oh, it's 60.
60 times 7.
I got 420.
420. Yep. So we're going to graph an angle of 420. That makes me nervous. You guys know that. 420 makes me nervous there because it's bigger than 360. I know I'm gonna have to go all the way around, but anybody help make it a little smaller for me so I don't become so nervous. Subtract 360, and what do you get? 60. All right, so I'm gonna graph an angle in. Oh, okay. I guess I don't have to call anybody there. Quadrant 1. Okay, everyone ready here? Because I know this is where we're getting a little confused from your pop quizzes. You start your arrow on the initial side. Always start on the initial side. Now, am I going to go clockwise or counterclockwise? Counterclockwise. I just went how many degrees right here? 360. So I just have to go that little more to the terminal side. All right, I don't need to go around again. Start on your initial side. So there's the angle. Now, without having to do much work now, what about the reference angle if I started with 7 pi over 3? Notice what the reference angles were. 5 pi over 6, pi over 6. Negative pi over 4, pi over 4. 7 pi over 3, what do you think the reference angle is going to be? Pi over 3. If you wanted to go and do the work to find the reference angle, you could, but it's still going to be 60 pi over 3. Questions, comments? All right. No calculator, huh? Look at us. What's the quadrant? What's the reference angle? Quadrant and reference angle. So I have 7 pi over 6. So you guys see pi over 6. Look back if you have to. No issues there. 7, Connor, pi over 6.
30 degrees.
Times 7.
Uh, 30 degrees.
3 times 7.
Oh, 3 times 7, sorry.
Pi over 6 is 30.
Yeah.
30 times this 7 they give me gives me the angle, which would be what?
Oh, 30 times 7. 30 times 7?
Okay, ready? Pi over 6
Yes.
is what? What have we been going over today? Pi over 6 is the same as what in degrees?
30.
30. What's with it?
7.
Times 7.
Okay. 210.
210. So there's the angle, 210. Now look, am I going to be critical if you guys have to go to the formula sheet and convert it, multiply it by 180 over pi? No, I don't care. I just think this goes a little bit quicker, and I think a lot of you agree with that today. So 210, what quadrant am I in? We'll get it. 1-8. Higher. Quadrant 4. Great job. No, 4? 4 is 270 to 360.
Oh, wait, no, sorry, 3.
Oh, is that what you meant? Yep. Quad 3. How about the reference angle? Based on what we've been doing.
30 degrees.
Here we go. Quad 3. And that doesn't matter anyway, the reference angle while I'm yelling quad 3. All right, I'm not going to waste time. I'll do this one. Reference angle, it was 7 pi over 6. So it's pi over 6, 30 degrees. And again, hey, is it wrong if you want to take 210 and you know the rule to find the reference angle is subtract 180? You get 30. Oh, 30 is pi over 6. That's fine. That's fine. Negative 2 pi over 3. I am going to finish up with somebody here. Pi over 3. 14. What's up, Emma? Here you go. Pi over 3 is what?
Pi over 3 is 60 degrees.
60 times negative 2.
Negative 120.
There you go. So this angle's equal to negative 120. You like those tricks, Ryan, don't you? Good talk. Be careful now. Negative 120. Where are you at? Negative 120. 16. I'm on fire today. Nope, not that one. 2's, Jeremy. What quadrant? Negative 120. Don't even think about getting it wrong.
Quadrant 3.
Yep. Reference angle. Reference angle. Can we, if not, I'll work through it with you. Can't see it quickly. 1-4. Hi, Emma.
Um, is it 60?
It is 60 in radians, though. It is 60 degrees, but I'm going to need it in radians. What's that? Pi over 3, yeah. And you guys can see, hey, it's always going to be that part there for the reference angle because I'm just multiplying it by a number. Yep. Let me just check something real quick before you guys get going. Because it's no delta math today. It's the next page of your packet. Okay, yeah, this will happen to you. Now look, if real quickly, let me talk. If it's not pi over 3, pi over 4, or pi over 6, let's just say it's pi over 9, you're going to have to convert. Okay, I'm not going to have you memorize a ton of things here. All right, so if it's not one of these three where you know it's 60, 45, 30, you're going to have to convert. So what I mean by convert is multiply it by 180 over pi. Yes, Jeremy?
But it would be easier if you had recognize pi as 180 and you do 180.
Okay, then you can go ahead and do that. Yep.
And get 20.
All right. Other questions? Yep.
For this, did you need the reference angle in radians?
Okay, here's my
Did it
rule,
say
Zach.
that?
Here's my rule, and everyone else, here's my rule. If the original problem is in radians, your final answer is in radians, regardless of my directions. Okay, if your beginning problem is in degrees, then your final answer can be in degrees. But this was in radians, so I'd like your final answer to be in radians. Okay, keep it the same. All right, go ahead, flip it over, get your Chromebooks out, take a look up on. Actually, I got to see if I posted it. I'll post it right now to Classroom if I haven't done it. And we can